Hello, welcome back. Today we're going to be talking about solving compound inequalities. The objective is by the end of this video, you should be able to solve and graph a compound inequality. For example, solve and graph an inequality like this or like this. Our first example, we were asked to solve and graph this inequality right here. Now what I want you to notice is that this inequality is different from the other inequalities you might have solved in the past. Specifically, you'll see that there is an OR in between two separate inequalities. What this means is that the left inequality is true or the right inequality is true. How we solve this is if there is an OR between two inequalities, we just solve and graph both on the same number line. So we're going to solve each inequality separately, and then we're going to graph both of them on the same number line. Let me show you. I'm going to look at the left inequality first. Need to get x by itself, so we solve in SADMAP order. We subtract or add first. I'm going to get rid of this plus 4 by subtracting 4 from both sides. This leaves me with 2x is less than negative 6. I then divide by 2 and I get x is less than negative 3. Or then I solve the right inequality. To get the right inequality by itself, I undo subtraction addition again. I get rid of the positive 2 by subtracting 2 from both sides, leaving me with negative x is less than or equal to negative 2, and then I divide both sides by negative 1, leaving me with x is greater than or equal to positive 2. When we divide or multiply both sides of an inequality by a negative number, it causes the direction of the symbol to change. It flips the inequality. So our answer to the instructions solve is right here. X is less than negative 3 or x is greater than or equal to 2. To graph this compound inequality, we graph it like a regular inequality. We draw a number line. This is our x number line since we're talking about x values. We're going to plot both of our numbers on our number line, negative 3 and positive 2. Since x is less than negative 3, we use an open circle. That means we cannot touch negative 3. Negative 3 is not a solution. And you notice we're going to shade all of the numbers where x is less than 3, or negative 3. So that would be going in the direction of negative 4. For the second inequality, we see that x is bigger than or equal to 2. We use a closed circle around 2. Since we can actually equal 2, we can touch 2, so I make a big closed in or filled in circle. And since x is bigger than or equal to 2, that means we're going to include all of the numbers bigger than or equal to 2. So I'm going to go in the direction of 3. It's going to include all those numbers. And there you go. We've solved and graphed an inequality that has an OR in between. This is called an OR compound inequality. Here's an example for you to try. Go ahead and pause the video, work the example out, and press play when you're ready to see the answer. For this example, I would solve the left inequality first by getting the y's on the same side. I'm going to choose to add 2y's to both sides. This leaves me with 6y minus 7. Let me make my 7 look like this. Is bigger than or equal to 2y, negative 2y cancel, positive 1. Notice again, we treat each inequality completely separately as if it were a separate problem. And then we'll graph both of them on the same number line. So 6y minus 7 is bigger than or equal to 1. We're going to add 7 to both sides, leaving us with 6y is bigger than or equal to 8. Divide both sides by 6, and we get y is bigger than or equal to 8 over 6 reduces to 4 over 3. Or, for the second inequality, we have negative y over 4 is bigger than 3. We write that again. To get rid of the divide by 4, I'm going to multiply both sides by a negative 4. Because negative 4 times negative y over 4, the negatives cancel and so does the divide by 4, leaving us with just 1y. Instead of greater than, it becomes less than since we multiply both sides by a negative. Negative 12. Oops. Y is less than negative 12. Now we're going to graph both of these inequalities on the same number line. Always start with the least number. Since negative 12 is smaller than 4/3, I'm going to write negative 12 first. 4/3 comes second. Since y is less than negative 12, I use an open circle since it doesn't equal negative 12, and I shade towards numbers that are less than negative 12, which should be to the left. 4/3, since it's or equal to, I'm going to draw and put a closed or filled in circle around 4/3. Since y is greater than or equal to 4/3, I'm going to shade towards numbers that are bigger than or equal to 4/3. The second type of problem we're going to solve today is an inequality where you have the variable, whatever the variable happens to be, in this case x, and it's between two different inequality symbols. Since x is in the middle, our goal is going to be to get x by itself in the middle and numbers on either side of the x on the other sides of these inequality symbols. Put another way, if there are two inequality symbols and the variable is between or in between, get the variable by itself in the middle. What we do to the middle, we have to do to both sides. First thing we want to do, just like when we were solving a regular equation, is we want to go ahead and simplify the side that has x in it. So I'm going to go ahead and split my inequality into three different sides: the middle, the left, and the right. And I'm going to simplify by distributing the negative 3. This gives me negative 12 minus 3x is less than 6 is bigger than or equal to negative 4. I still need to get x by itself in the middle, so I'm going to solve in SADMAP order. I'm first going to get rid of the minus 12 by adding 12. But here's the weird part. There are three sides. But that's okay. What we do to the middle, we do to all of the sides. So if I add 12, I'm going to add 12 to every side of the inequality. There happens to be three sides: the left, the middle, and the right. So negative 4 plus 12 is 8. Is less than or equal to negative 12, positive 12 cancel, negative 3x, which is less than 6 plus 12 is 18. Still need to get x by itself, so I divide all three sides by negative 3. Since I divided by a negative, my inequality symbols change directions. I have negative 8 over 3 is bigger than or equal to x, which is bigger than negative 6. Typically you'll see this written in order from least to greatest. Since negative 6 is less than negative 8/3, you'll typically see the answer written like this instead, where you see that x is bigger than negative 6 and x is less than or equal to negative 8/3. When we draw our number line, we plot both of our numbers, negative 6 and negative 8/3. Since negative 6, you notice that x is bigger than negative 6. We just use an open circle since it's not or equal to negative 6. Since x is less than or equal to negative 8/3, we use a closed circle. This one's different than the one that has an OR, because you notice that all of our x values are between the two numbers. That means all the numbers between -6 and -8/3 will make this inequality true. So we shade all of the numbers in between -6 and -8/3. Again, since x is bigger than -6 and less than or equal to -8/3, we shade all of the numbers in between -6 and -8/3. Here's an example for you to try. Please go ahead and work it out, pressing pause, and when you're ready to see the answer, please press play. For this example, I would go ahead and simplify the middle of the inequality first. I would do this by combining the -4x, that's a -4x, and the positive 6x to give me a positive 2x minus 5. Is less than or equal to 4 and is greater than -2. I then need to get x by itself by undoing operations in SADMAP order. So I undo the -5 by adding 5, and what I do to the middle I have to do to all three sides. -2 plus 5 is 3, is less than 2x, is less than or equal to 4 plus 5, which is 9. I then need to get x by itself by dividing all sides by 2. Giving me 3/2 is less than x, which is less than or equal to 9/2. We can then draw our number line and graph all the solutions to the inequality by plotting our two numbers from our inequality. Since x is bigger than 3/2, we use an open circle. Since x is less than or equal to 9/2, we use a closed circle. And since our x is between those two values, we shade all the values in between because all those values are solutions to the inequality.